From the year 2008, we have visited China on numerous occasions, investigating the best possible foundries, the best possible fabricators, the best possible suppliers of equipment. Importing equipment from China is a new thing for South Africa. For line phase 2, the decision was taken to import selective equipment from China, and a tremendous lot of work went into it to find the right company, the right equipment and the right product at the right quality. According to our P2P policy and procedure, we made the decision to go out on tender, and the tender was awarded to the Beijing Access Group, whom are stationed in Beijing. The CEO of the company, Kobus van der Walt, and they have established office in Beijing. At the time when the contract was awarded, it was awarded to NHI, whom are the fabricators of large machinery. They are well equipped to deliver a quality product on time and within budget. The costs incurred for purchasing the kilns from China was a huge cost reduction on the initial capital for line phase 2. The Beijing Access Company made use of an engineer by the name of Eddie Durant. Eddie is well acquainted with equipment from China. The direct services of Eddie Durant was utilized for the equipment inspections, with a third party being involved for the QS, the quality.
My construction manager, Kobus Malan, have done intensive planning for about 6-7 months regarding this, and he managed to bring a team together with all the technical expertise and considering all the risks.
On commencement of this project, the second phase of Project Lion, we knew that we're going to have a lot of challenges. It all started off with everything being fabricated in China and was shipped down to the harbour in Richards Bay. And the first challenge that we had was transporting the sections from the harbour up to site. Well, it took on an average between 2 and 5 weeks per section. And the sections varies in weights from around about 87 tons to 140 tons.
The kilns are 5.5 meter in diameter by 80 meters long. The kilns are supplied in 5 sections, which are then assembled, and that forms the total kiln.
URM was involved in the first phase in 2005 with phase 1 line project, and we were lucky to be awarded the kiln installation and the molds on phase 2.
For Xstrata to have done the work, the assembly and the installation of the kiln, a selected team was put together from certain companies and certain individuals to manage this installation at best practice.
The support of Johan and Jerry from UFS made it possible for us to consider a few options, and although it was never done before, we could, with their assistance and their professional approach, make an easy decision to assemble on ground level and do the heavy lifts after.
We had a look at planning this with Sarens and Ale Company to do this on the ground, or to use a different method than what we usually use for installing the kiln sections.
Although it was very similar executing the task on the ground and in the air, there was a lot of challenges that's got to be faced. We had to align it on the ground firstly, pre-assemble, dog it up, align it, and then weld it.
A combined effort between the different companies came to install this on the ground, on rollers, to do the welding of the kiln sections on rollers after they arrived from China. In loose sections, we welded them together on the ground, the same method that we use when we're installing them up in the air, and then to look at two different companies, the L section where they use cradles to move this, or to use heavy lift cranes, a 600 and an 800 ton crane, and the SMPTs to move this in position and lift it onto the kiln plinths. We opted to go for the Sarens option.
The welding took around about 6 to 7 months to complete the welding, and then the installation of the riding rings was a challenge by themselves, which also varied between around about 90 to 100 tons, which had to be installed in position on ground level.
We welded them on the ground. After we have completed them, we had them QC'd, checked, all the welding was checked, and then we got the companies involved with meetings once a week that we could have a look at the best way to move them from the laydown area where we've put them together to the area on the plinths where we had to install them.
Now the planning for these took around about 6 months to get everything perfect. And with the professional help of Sarens and UFS, we achieved those. Then the real big challenges came. D-Day, as we called it, to lift these things in. We had to calculate on the rain, and we decided to do it over a weekend period where there's very little people on site to reduce the risk. As we lifted the first sections onto the SMTPs, it started raining. The hard standing was a problem. We couldn't get it through, but eventually we got it through.
The engineering department asked us to facilitate the risk assessment process for the big lift with URM and Sarens. After numerous meetings and changes in the method statement, we came up with a risk assessment that was acceptable, taking all of the risks on site into consideration, such as overhead cranes. We had cable tunnel running underneath, and we had to look at the hard standing. There was also inspections that had to be conducted to ensure that all of Sarens' equipment complied to the Occupational Health and Safety Act.
Well, on completion of the first sections, we brought the cranes in, and that was a challenge by itself, especially on the SD side, because these were crawler cranes, a 600 tonner and a 500 tonner, which had to be pre-assembled in situ, lifted up, and then all the rigging studies and risk assessment around that had to be put in place.
After numerous meetings, the risk assessment team came up with an acceptable risk assessment which identified all the necessary risks.
After all this planning was done and all the paperwork and everything was put in place, the final big days arrived. We got hold of everybody that was involved with this. We went through this for a final time after all the planning.
After completing the risk assessments, the challenge was to ensure that everybody worked according to the method statement. On the day of the lift, we started discussing the risk assessments with the DSTIs and all the necessary SD documentation with everybody involved to coordinate this lift. After everybody understood what had to be done, we commenced with the lift.
We moved the cranes in position and we started with the lifts. We lifted section D, 3, 4 and 5 first. Those sections weighed around about 425 tons.
We lifted this onto the SMPTs, one section, one kiln section at a time. It was kiln D that went first. We moved that down to the plinths where we moved the cranes in, and on a tandem lift we lifted sections 3, 4 and 5 up onto the plinths.
The few challenges we had on the day of the lift with the extreme weather conditions was overcome through extremely good teamwork of everybody, and we managed to do the lifts without any incident. We're grateful for that. Everybody was safe, everybody worked according to the plan, and we managed to get everything lifted in position.
Then we went back for sections 3, 4 and 5D. We moved that around to the kiln piers 2 and 3, where we lifted these in position. Then we had to move back to the laydown area to get hold of sections 1 and 2. This is the most difficult part of the lift.
Then the real challenge started. Although it wasn't the heaviest part of the lift, it was the biggest challenge that we had to do there, because we had to go down on an angle. The one crane, the 600 tonner, was standing at a level of about 12.7, 12.8 meters lower. One of the challenges was the cable tunnel. There's a cable tunnel running for approximately 48 meters, exactly in the crawlway of the crane. If you take the weight of the crane, the weight of the section, we had basically about 1,000-ton point loading in that section. So we had to have props designed and prop the tunnel to prevent it from collapsing. We surveyed all of this and we installed it. We had closed circuit television cameras underneath to see if there's any movement when the cranes moved into position.
Eventually, when all this was put in place, we actually went in. We had one crane standing on the top by pier 2, and we had the other crane, the 600, standing at the bottom, and that we lifted this kiln section 1 and 2. It then moved forward. The crane, the 600 ton, moved forward, and the 500 slewed, and we got this turned and put it down on its rollers with strong backs inside, lowered it in position, and kept it there till we welded all the strong backs inside and the dogs. And then we went back, and it was the same with this second one.
The total weight of the kiln sections was in the region of heavy lift was 580 ton in totality. That's the kiln sections, the 3 sections with the riding ring. And I think, if I'm not mistaken, that hasn't been done for quite a few years in South Africa. And we couldn't have done it with the teamwork of everybody involved. So we are very proud and very happy to say that we have achieved it safely. And talking to the contractors involved, I think we also set the standard in the sense that with the technology available in South Africa in the form of a company like Sarens with all the heavy lift cranes, kiln assemblies will never be done the old conventional way again.
The team to manage this project was a hand-selected team with a few individuals that had the relevant experience to do the work professionally. I'm really proud of the team, each and every member in the team that contributed to the success of this project.